Welcome back to YMT114, Principles of Software Engineering. Today we'll be speaking about Chapter 6, Architectural Design, and this is the first part. I'll be covering architectural design decisions, abstraction, representation, models, and the views of architecture and the architectural views. So the principal idea of having an architecture while designing or developing a software is exactly composing or creating an organization of the overall structure of the system. So it's a view of the building diagram or components of the whole system, overall system. We don't speak about components by themselves. No, we speak about these components, how they fit together and how they are linked together. So try to distinguish between architecture and design itself. Design is a process, yes, within the development of a software, but it's actually a sub of the whole architectural design. Architecture is concerned with the whole thing, the whole software view as an organization. So that's why it's extremely critical while designing a software. Why? Because it identifies actually the main structure of the components and the whole system, by the way, okay, and the relationships between the components. And that's why we think of architecture, specifically in software engineering and software design, as a very critical step or process. What's the output of an architectural design? Or if we say an architecture of the system, what could be the output? It's a model. So this model is a representation of boxes and links, or you can say lines, so to show the components and their communications and how they are organized. I again try to distinguish between design and architecture. Design is concerned about with the components of the system rather than the whole system as overall. Okay, this is extremely important. How about agility and architecture? In agility, actually, we spoke about it also in incremental design strategies, that we usually do not care much about the overall structure or architecture of the software. Rather, we create draft and see the opinion of the customers or the clients, and then we create another version and so on until we reach to the final version. So speaking about structure or architectural design at the beginning means what in agility? So it contradicts the concept itself. However, in software development, we cannot disregard the architectural design at all. Why? If we disregard it at all, that means we don't have any architectural design from the beginning for a very serious, let's say, software development. In that case, we cannot guarantee later on our performance or our actually the outcome of our system. Why? Now imagine we need to refactor the system itself to fix some problem. If we do this step after designing the whole software, it's extremely expensive. It will take time and effort. And in that case, we will not actually save time and money by just applying the agility or incremental design process in this case. No, rather we should have at least a sketch about the architectural view of the whole system and how it is organized and distributed. Then after that, we decide on if we can go for agile development or incremental design or whatever strategy that we have to apply while developing the software. All right, this is a simple example to show you how we can architect or how we can actually build an architectural view of a system. Now this is an architecture or an architecture actually of a system, and the system is actually for packing robot control system. Now look, as I said, boxes and lines, and these lines are actually ended like arrows to show the direction of the communication because these are components and they have to communicate with one another, or maybe the communication should be in one direction or maybe in two direction, bidirectional in that case, like for example these. So we represent some units or modules to communicate with other modules or pass output to other modules and so on. This is a view. I will criticize two things in this architecture, and then I'll explain about them later on. Now, it's too abstract. For many people or many individuals, when they see such a design or such an architecture, they wouldn't be exactly able to understand things related to these units. Too abstract. And what kind of relationship or connection do we have here? Okay, it's just moving from like one directional, but what's its essence? So these are the two points that we usually get stuck with while speaking about boxes and arrows in architectural design, okay? The abstraction, what kind of levels do we have for architectural abstraction? And we spoke about abstraction actually before. So the idea now is we have two main abstractions that we can have while designing the architectural view of a system. The first one is actually designing or having an architecture for actually small scale. So this is what we call architecture in the small. It's very similar to programming in the small before, if you remember in chapter 1. The idea is architecture in the small is concerned with only individual programs and how they are decomposed to components. You can think of flowchart is roughly, of course, non-official speaking, an architecture or an architectural design of a program. But in that case, as we said, what we are concerned with here is a single program and how its components are related or decomposed, or we can actually create the program from these components. We have the second type, very similar, as I said a few seconds ago, architecture in the small and architecture in the large. Architecture in the large is concerned with actually the architecture of complex systems, enterprise systems, systems that may include other systems or programs or components of programs. So all that type of architecture. And in that case, we usually care about architecture in the large while dealing with software development. However, we cannot ignore this one because we can decompose even complex systems to small programs and then have their own architecture, especially for the development team, those who implement the implementation, those who write codes in that case. What kind of advantages do we have for the explicit architecture? First of all, we spoke about this before, and let me remind you again, when we have a visual aid, we can communicate easily with stakeholders. And as I said, not today, I said before, when we deal with stakeholders, we don't assume that they have the technical knowledge or the technical background to enable them to understand things when we speak about them from our technical background. No, but when they have a visual aid, an architecture design, things like boxes and arrows and lines connecting them as components, they will have a rough idea, a better way for discussion, better way for understanding. Yeah, this is the first advantage. The second advantage is actually good for analyzing the system. So it's a base for analysis. What does it mean? We can think about how we can meet the especially the non-functional requirements while designing the architectural view of the system or the architectural composition of the system. Think about the non-functional requirements and their role in the overall performance of the system, how you can meet them it will be easier for you to see it and visualize it while you have an architectural design. Now, one more thing, software systems are not generated from nowhere. Usually they have similarities, especially for those apply the same concept. So for those, if we have an architecture designed for, let's say you have an architecture designed for some software, and after some time you get a request for a very similar software, can you reuse that architecture? Yes. You can modify it a little bit and reuse it, or reuse some of its components and so on. So for reuse purpose, it's also useful. That's the third advantage. The representation of the architecture, or the architecture of the representation, how can we represent it? I said earlier we can use the block diagrams, boxes and lines. So boxes can represent entities, or not necessarily boxes only. We may have some oval shapes and so on, but these are like the blocks or the shapes that we have for entities can be connected, and then we will show the type of the connection between those as a relationship. And this is exactly the case. And we can use those also for the documentation. It's possible, and it's one of the reasons that we use actually architectural representation. We will see it in a while. Okay, now I said these two criticisms earlier, or two critics about the box and the block diagram. The first one is actually the lack of semantic. It's not easy to show the type of the outcome the component is producing, and what kind of relationship or communication type also we have between the entities, their properties. These are actually common critics for such a representation, yet it's available and it's used, still in use, even nowadays. I mean, as a process, or as a stage in the software development. Okay. Now, if you want to provide some semantic or some meaning about the components that you have and the type of the relation, you can add that, but it will be too complicated. And it depends, actually. You can add for some of the models that you have, or some of the communications that you have, but not for everything. If you do that, your system will not be abstract anymore. Okay. We said about this, but let me repeat again. The box and line diagram, or box and whatever the communication arrows that we have, is too abstract. Okay. As I said, it's too abstract. It doesn't show actually the nature of the component, the type of the relation, the visible properties, and so on. But it's a very good way for communicating with the stakeholders, especially those who do not know much about the technical knowledge needed for software development. Okay. What kind of uses do we have for the architectural models, or the architectural view or design of a system? The first one is a way for making the discussion easier, facilitating the discussion with stakeholders. As we said earlier, a high level of abstraction allows the stakeholders to properly communicate and comment and give their feedback about things without having to get stuck with the details of the system. Okay. The second thing that we have as a use for the architectural model is the documentation. Why do we need to document an architecture or a system in terms of its architectural model? Because we may reuse it. Plus, we may need to decompose the system and see sometimes how its components are being interfaced. So we get back to the architectural model of the system, or the view of the architecture, and then we decompose, and maybe it's needed for refactoring, or needed for update, or sometimes for maintenance purpose. Okay. How can we decide for an architecture? What kind of architecture can I follow, or what would give me the decision, the proper decision to go for one architecture over the other. We have different types of architectures. We will see them and go through them in next sessions or next parts of this chapter. So the idea of deciding on which architecture to use is not just a basic or elementary idea. It has a relation with different things. The essence of the software itself, the main requirement from the software, plus the kind of application, what kind of application we are actually basing all our software on, in order for us to develop it. So, well, what kind of also non-functional requirements we have. So these matter. So we need to think about the main characteristic, especially for non-functional requirement. What is it? Do you speak about performance? Or are we considering safety or security? Or are we speaking about maintainability or availability? Which one we need to address most? And based on it, we can come up with a decision. And this decision should be based on some sort of compromise, and I will explain why. Now think about these questions that we may ask. First of all, we think about, is there any generic application architecture that can act as a template? So if there is any pattern I can use as an architectural design or a model, why do I need to create one? So if there is available, we can adapt it. Okay, how will the system be distributed across the hardware, cores, or processes? The essence of the application of the software that we have, is it distributed? Is it layered? Is it the type of process, transaction, whatever? So these things will matter. What architectural patterns or styles might be used? So I said earlier, well, if we come up with a generic application architecture, then maybe we can use some patterns also. Okay, what will be the fundamental approach used to structure the system? So I said the idea is based on security, the idea is based on safety. What kind of outcome I need to, or feature or characteristic I need to relate more? Also, sometimes in implementation itself, what kind of paradigm are we using to implement the software? And then we need to structure things related to that. Also the strategy that would be used to control the operations of the operation of the components in the system. This also will matter while creating or modeling an architecture of the system. How will the structural components in the system be decomposed into subcomponents? Also, the decomposition of components into subcomponents matters. Why? We will see it in the next part of this chapter, how it matters actually, because we have some systems created from, you can say, fine component, smaller component than bigger ones. Like we can centralize some systems on few components based on some customization, or we can go for fine grain, you can say, components, tiny components that link to one another. What architectural organization is best for delivering the non-functional requirement of a system? So we need to look also for the non-functional requirements and see which organization is best, or architectural organization is best to meet these requirements. How should the architecture of the system be documented? Also, the documentation matters. These are not all the questions that we have, but you can say the main ones. You as a designer or a developer of a software may think of other questions also. And the answer will be, based on the answer, you will come up with the architectural model that you have for your system. All right, reuse. As I said earlier, creating or modeling an architecture of a system usually is not totally isolated. We have similarities. We have a lot of similarities in software systems. And for that case, we can reuse. So we would end up with, let's say, maybe we have 10, 20, 30 generic architectural models, then we can apply them to most of the software systems that we are supposed to build. So these what we usually call architectural patterns. Sometimes also people refer to them by design patterns, but they are like styles or templates that can be reused, or in basic sense used in this case. We have the generic form of them. We can apply them for a software system that fits this kind of generic view or generic architectural model. Okay, we can instantiate them in another sense. All right. I said earlier, we may have some system characteristics, especially non-functional characteristics we speak here, that our system may be built around it. So in that case, we can come up with a decision based on some architectural view. So let me give a simple example. Performance. If we are concerned with the performance over other non-functional requirements, then we need to localize the operations in few components and make these components large. Okay? Why? Because if we keep having interfaces, so if we have many components, small components, and these components have different interfaces and communication in between, the performance will be less. It will not be exactly like when we centralize and localize the whole processes in large components without communication or interfacing in between. Security. If we are thinking about the security of a system, then we think about layering the system. What does it mean? Creating layers of the system and putting the most vulnerable processes or components at the innermost layer, where the security is too tight, or the hardest in that, you can say, layer. Okay. How about safety? We can localize also the safety features in small number of subsystems, so in that case we can lower the cost of having any problem in the system. Availability. We may have redundant components to maintain the availability of a system, and also we may think about some mechanisms for fault tolerance. That means having a fault in the system, but yet the system is running. You may think about a backup or backup components. Maintainability. Now, if you think about the maintainability of the system, how to run, it's a bit similar to availability. Rather, there is a critical critical difference in this case. Maintainability here is how can we replace components if there is a problem with one component, and maintaining the system in use. In this case, it's exactly opposite to the performance. Instead of using large components, we minimize the components. We create fine-grained components, smaller components, as small as possible, and we make them replaceable, so that if any one of them is being damaged or any problem happens to it, we can replace it, so its backup is there. Or even if we need to change some components or update the system, we can come up with our strategy with no problem in this case. Now think about a problem, and I may ask this question in your assignment or quiz or whatever. If we have two requirements, performance and maintainability, how can we manage? They are contradicting each other. So while deciding the architectural view or the architectural modeling of a system, how can we manage having the performance and the maintainability as two features that we need to have? There must be a compromise in that case. So we must compromise. So performance versus maintainability, for example. In that case, we need to think about the best strategy to come up with a trade-off. That means somewhere in between the performance and the maintainability. Architectural views, as I said earlier, creating an architectural model of a system is not a straightforward and an easy process. And in that case, we asked different questions, and we said about these questions, if we properly answer these questions, we can come up with a proper model for the architecture of the system. Now, Let's ask these two questions. What views or perspectives are useful when designing and documenting a systems architecture? So we speak about views. Why? Because the architecture or the architectural model of a system may be represented by different views, and I will show you in a few seconds. Also, the notations should be used for describing the architecture model. What kind of notations? Are we going to use UML or any other way, or whatever sort of way you may think about or method you may think about, okay? So we need to answer these two questions, and based on them we can come up with like the proper view or the proper model for the architecture. Now let me just add another thing. Think about these perspectives of a system while we are modeling it. How the modules are decomposed. Our system is composed of modules, right? Some modules, or maybe many modules. All right. How about while the system is running, while the processes are running, or during the runtime of the processes, how the modules or the components are interacting with different, you can say, parts of the system, and also how the components are distributed on the system or across the network, for example, while the system is running. Okay, so in these questions, when you answer them, they will give you a clear idea about the views that we speak about. Now let me show you here. Architectural views, there are actually different models for viewing the architecture, but this is the most common. We call it 4+1. For these are for actually logical view, physical view, and the process view, and the development view. And this is a system architecture, how we see it, how we look at it, or how we view it, the perspective, plus the way we realize them, use cases, for example, or whatever way we use for the realization of these views, okay? For example, if we speak about the logical view, we speak about how the objects of the system are viewed in an abstract way, or the key abstractions, how they are represented in terms of objects or objects of classes, for example. And you may ask, what's the point? Why do we need even to have such a thing? We may need to think about this logical view for relating the requirements to the entities. And this is extremely critical and important, okay? Maybe also you may ask, what's the point about relating the requirements to entities? Well, it's extremely critical in the implementation of the system, plus also for the maintaining of the system. Also, if you have any fault, how to refactor and how to fix the system. These are extremely important. The process view. Now, for the process view, what we are looking for here is actually the runtime, how our system is composed from different, you can say, or interacting processes during the runtime. And in this case, actually, we care about such a view. Why? Because we need to give a judgment about non-functional requirements. For example, the performance, the availability, maintainability, and so on. How about the development view? The development view, actually, we think about the decomposition of the system itself for development. And in this case, we speak about the breakdown of the components. And when we speak about the breakdown of the components, we speak about the components of the system. And now you say, why do you need to address? You may think about it. Why do you need to address the decomposition of the components or whatever the units or the modules of the system? Because simply we will know to whom we will assign some tasks of implementation, like the implementation team or one of the implementation team. We can assign some components to be implemented in that case. How about the physical view? The physical view, actually, we address the distribution of the system by itself on or across the hardware and we may think about actually different systems that can be distributed, our system can be distributed across. So these are the 4 views plus one, the relating them using use cases or similar application of UML. This is the idea of actually the 4+1 model, okay? Now, as I said earlier, we usually use a basic way of representing an architectural view or modeling an architecture. We use the boxes and lines or arrows. In that case, we can use UML, the Unified Modeling Language. It's extremely easy for you to use UML for such a purpose. However, some experts actually say that UML is too high level for such a thing. It's extremely abstract. So we need some more details. And some experts recommend the use of architecture description languages, ADLS. While in this course we will not discuss the ADLS or any of them, but you may think about it, you may search and see how it is used. UML is actually too simple for this course and we can use it. The idea with ADLS or ADL itself as a language or architectural description language, but we speak about languages, not only one. It's a bit more, you can say, advanced for normal users or non-professional users. So it's somehow at the expert level, and for this purpose, it's not quite often, it's not known, it's not common to many people. I mean, especially when we speak about non-technical. Unified modeling language is widely used. Even some non-technical people use it for their own purpose, for their own ease. But for ADLS or whatever architectural description languages that we speak about, usually it needs some level of expertise. Well, this is the end of this part 1. I'll record other sessions for the same chapter. Until then, have a good time. Goodbye.